Today we are going to be talking about operations and composition of functions. So the first thing we need to talk about is some of our notation and what that means. So when you see this notation, f plus g of x, that just means f of x plus g of x. You are adding your two functions. Difference, same thing, f minus g of x, you're subtracting your two functions. We can also take the product where we multiply them, or we can divide them. That would be the quotient. So these are our operations. And then the new thing we're going to talk about today that looks a little different is composition. And so this notation can be written two ways. This is read as f of g. That open circle tells us we're taking composition. Or you could see it in this notation where the g of x is inside your parentheses. And that's where we're substituting one function for the variable of another. And you have seen this when we substituted expressions into functions earlier in the year. We just weren't calling it composition. So first thing we're going to do is a quick review of domain. So we've got these four functions here. Remember, our domain restrictions are we cannot divide by 0 and we cannot take the square root of a negative. So starting here with f of x, I've got a square root, which means all of those values have to be positive. So that domain is going to be that x has to be greater than or equal to 5. On g, I've got my restriction that I cannot divide by 0. I just have x in my denominator, so x can be any number except 0. On h, I don't have a radical and I'm not dividing by x, so my domain for that one is going to be all real numbers. Same for k. No division by x, no radical, means I have no restrictions and it's all real numbers. So that's just to keep you thinking about domain and practicing what you've already learned earlier this year. So let's get into the new stuff. Operations of functions. H plus k of x. Remember, that just means I'm going to be adding my two functions together. So here's h of x and k of x. It's going to be 2x squared plus 3x minus 1 plus 4x minus 5. And now I'm just going to combine all of my like terms. And there is my final result. All right, C, h times k of x. Remember, this is just going to be multiplication for my two functions, k of x. So this is going to be a trinomial times a binomial, 3 terms times 2 terms. So that means I'm going to have to make sure I'm doing multiplication 6 times to get the correct result. So let's start with our 2x squared. We multiply that on the 4x to get 8x cubed. Then we multiply on the negative 5 to get negative 10x squared. 3x times 4x gives us 12x squared. 3x times negative 5 is minus 15x. Then the negative 1 times 4x is minus 4x. Negative 1 times negative 5 is positive 5. So you should have 6 products. You do multiplication 6 times and then combine your like terms. 8x cubed plus 2x squared minus 19x plus 5 is our final result. All right, on to D, f plus g. So I'm going to take f of x plus g of x. So that's going to be the square root of x minus 5 plus negative 3 over x. Now, refresher from our quick works, we cannot add radicals that don't have the same thing inside of them. These don't match, so I cannot condense these any further. So I'm just going to rewrite it as minus 3 over x since I have that plus a negative value, but this is as far as you can go. You cannot combine these any further. Okay, then on to E, f minus g, f of x minus g of x. And this is where I'm going to encourage you to put your second function in parentheses because you need to make sure you're distributing that negative, especially if you have more than one term in here. This negative is going to be changing the sign for each of those terms. So I've got, again, the square root of x minus 5 minus a negative, that becomes positive. And just like on D, I cannot combine these any further because they don't match. They're not the same. All right, on to F. F of x times g of x. We're going to be multiplying them. So x minus 5 times negative 3 over x. Now remember, we've got an invisible denominator here of 1, so this is just top times top, bottom times bottom. So negative 3 square root of x minus 5 over x. All right, lastly, we're doing f of x divided by g of x. That's what that division is. So the square root of x minus 5 divided by negative 3 over x. So again, that imaginary denominator of 1. So this is division of fractions. Keep, change, flip. X minus 5 over 1 times negative x over 3. So it looks similar to our answer from F, but our x and our 3 are swapped. Okay? And that's it for operations. Now let's talk about compositions. Compositions just means you are substituting your function into the variable of the other. So everywhere that you have an x, you're plugging in your other function. So f of g of x, another way to see that would be f of g of x. So I'm plugging g into f. So I'm plugging in this entire thing, the square root of 9 minus x squared, in place of x in my function. So that's going to be the square root of 9 minus x squared minus 9. Well, when I square a radical, that gets rid of my radical. So I've got 9 minus x squared minus 9. My 9's cancel, and I'm left with negative x squared. Now the domain of that is going to be all real numbers because I'm not dividing by x and I don't have a radical anymore. So that domain is all real numbers. Okay, let's practice that again. Here I'm looking for g of f of x. Another way to write that would be in this notation. So this time I'm plugging f into g. I'm plugging in x plus 3 everywhere that I have an x in my g function. So that's going to be x plus 3 squared minus 2 times x plus 3 minus 15. Again, make sure you're using parentheses so that you remember to distribute, especially when you have negatives. Now, when you square a binomial, you are not distributing the square. That would be foiling. X plus 3 times x plus 3. Make sure you're foiling here. So that gets us that. Distribute the negative 2. And then we're going to combine our like terms, and our final answer is x squared plus 4x minus 12. Okay. Another way that you might see composition of functions is when we're given data points from each of our functions. So here are some points on our graph of f, and here are some points on our graph of g. So if I want to find f of 1, remember if you were given a graph and asked to find f of 1, what it's asking you to find is what is the y value when x is 1. So looking along my f function table here, this is where x is 1. And when x is positive 1, y is negative 1. So that's f of positive 1. Now I'm going to do the same thing for g of negative 1. I'm looking for my x value of negative 1, and that's here, and my y value is negative 2. So then on C, when it's saying find g of f of 1, I find it's easiest to rewrite it in this notation and work from the inside out. What is f of 1? Well, we just found that in part A, and that's negative 1. So now I'm going to be finding g of negative 1. Well, g of negative 1 is negative 2. We found that on part B, and so this is my final answer. So you're working from the inside out. First, you're finding f of 1, which is negative 1, which means you're now evaluating g at negative 1. So composition of functions. We're plugging functions into each other and evaluating. Operations, we're adding, subtracting, multiplying, and dividing. So this is adequate information for you to be able to do your homework, and I'm signing off.